A couple of econ formulas involving integration. Definition. If a company's profits rely on a function of time, like a pump at an oil field decreases its productivity over time, we say the company has a continuous stream of income. So if a company has a constant stream of income, like a subscription service or something, that would still be a continuous stream of income, but we wouldn't really need calculus to figure out like the total income over a period of time. So we're interested in streams of income that change over time. So the rate at which the money's coming in is somehow changing. It's probably decreasing, right? Like any kind of equipment depreciates, or like an oil field gets tapped of resources. So we're given a rate. We want to figure out like the total net amount of income we're earning from that stream of income. So given a rate, want an amount of stuff, that should trigger us. It's like, oh, we have to integrate. So if we have an expression for the annual or monthly or whatever rate of income given by our income stream, f of t, the total income from 0 to k years is given by just that. It's just the integral from 0 to k of that rate, right? Because the integral is the reverse of a derivative. And if we're given a rate, we integrate it to figure out the amount of stuff that happened. Example, find the total income over 10 years for a continuous income stream with an annual rate of flow at time t given by 8,500 e to the negative 0.2 t dollars per year. So you're going to see that a lot where it's like an exponential with it to the negative something t, because that gives you like a decreasing exponential curve. So it might start decreasing kind of a lot at first and then sort of level off, but it's still a decreasing function. If this were an increasing function, well, we'd be in good business because we just keep getting more and more income, but usually that's not the case. So that's a pretty simple setup. It's just the integral from 0 to 10 of 8,500 e to the negative 0.2 t dt. This would be one of those times where it's maybe good to pause the video and just try to do this on your own, right? You can do this. I just want to show you some good definite integral habits here to where you can do this with minimal fuss, and at some point it's just going to involve a calculator. So zap that constant outside. Right? We always want to take constants out because it just makes the final calculation a lot simpler. That is basically, that's a substitution now. We're going to say, okay, u is negative 0.2t. But you see this kind of expression so much that at some point you should almost be able to do this without being able to do the substitution. What's essentially going to happen here? We're going to have to divide by negative 0.2, because think about like the chain rule. If you were to take the derivative of e to the negative 0.2t, would be multiplying by it. So to integrate that, it's just going to be e to the negative 0.2t divided by it. But let's actually do it. So if we let u equal our little function of t up there, then du is just negative 0.2 dt, right? It's just the derivative of negative 0.2t. Divide by that negative 0.2. So it's negative 1 over 0.2 du equals dt. In this case, well, 0.2 is 1/5, so it's like negative 1 over 1/5, so why not just call that negative 5? Punch it into your calculator if you don't believe me. So we're just going to have a factor of negative 5 that pops up in our final result. That's all, and that's going to come out front of the integral as well. What I kind of like to do with these is just ignore the definite integral for a second and just set up like the antiderivative, and then at the very end just punch in that 0 and that 10. We're not quite dealing with it yet. So the negative 5 comes out front. That gives you negative 42,500. And then just plug back in what u was in the first place. And now we're going to evaluate it at the upper and lower bound. So it's just that times e to the negative 0.2t. There's a way to do it in a definite integral where you change the upper and lower bound. I don't think we need to do that ever in this class, but if you were to take any kind of Calc 2, you would need to do that, but we can get away without doing it. All right, so just keep that constant on the outside and then just evaluate e to the negative 0.2t from 10 to 0, which means you just plug those in. So it's negative 42,500 times e to the negative 0.2 times 10 minus e to the negative 0.2 times 0. That second term is just e to the 0, which is just 1. You might be getting a little nervous here, being like, wait, isn't this number going to be negative? No, it's not. Trust the process. That thing inside the parentheses is also going to turn out to be negative. So the final answer, which is like net money, we would hope that that would be positive. Okay, so the first one just turns into e to the negative 2, right? Minus e to the 0, and then I would just use your calculator for all that, and just, again, trust the process. That comes out positive, and it comes out to $36,000, $36,748.25. Now suppose that we are taking our continuous income flow. As that money comes in, we are investing it. So we are investing it at continuously compounded interest, which is that formula A equals P times E to the RT. So that's technically the best way to invest money. Earning interest rate R, whatever it is. The present value of that income stream is the value right now of the income stream that we know will be earning money for the next K years. So let's say we want to sell our piece of equipment because it's getting old or whatever, but we know that that piece of equipment is going to be generating, not only generating interest, but not generating income, but generating interest on top of that income for the next K years. Taking that into account, like, what is this piece of equipment worth to us right now? And then later on, which is easier, we'll figure out how to do the future value, which is like, hey, what if we hung on to it for K years and then sold it? What's the value to us then? So companies make these kind of determinations when they decide whether or not to upgrade equipment or, get a new factory or whatever. So if we have an expression for our income flow, f of t, then that's how you figure out the present value. So this is almost like working backwards in time. So taking that e to the RT that's going to be generating us income, if we multiply our integrand by e to the negative RT and then integrate that, that's what gives us our present value. So that's the formula. You don't have to memorize it, just there it is. So there is a t inside the integrand. So we may write inside that exponent, so we may have to do some kind of a substitution or something on it. So here's an example. Okay, we have another continuous income stream. It has an annual rate of flow given by f of t equals 9,000 times e to the 0.12 t dollars per year. So that's still an exponential with a little small number next to the t. We want to find the present value of this income stream for the next 10 years if we're investing money at 6% interest. So let's think about our integral before we set it up. It's going to be the integral from 0 to 10 of f of t, which is 9,000 times e to the 0.12 t, and then times e to the negative rt. So it's going to be e to the, now remember, it's not going to be 6. I'm not going to tell you that. You never do math with a percent. It's going to be e to the negative 0.06 t. There it is. So we'll do a little bit of algebra first. First pull the 9,000 out, right? That's a good habit. And then just remember how exponent rules work. E to the 0.12 t times e to the negative 0.06 t, you add those exponents. So really it's 12t minus 0.06. I'm sorry, 0.12 minus 0.06 is positive 0.06. Okay, so it's an integral a lot like the last one. And just like the last one, now I'm just going to kind of skip this part because all that's going to happen is we're going to end up dividing by that factor of 0.06, right? So there you go. Let's jump right to that. So when you divide by that 0.06, it can of course come outside. So 9,000 over 0.06 times e to the 0.06 t evaluated from 5 to 0. You divide by a number like 0.06, you get a bigger number, so that's 150,000. Again, just plugging and chugging. E to the 0.06 times 5 minus e to the what turns out to be 0, and e to the 0 is just 1. So that gives you, right, e to the 0.3 minus e to the 0, which, again, just trust your calculator, double check. I would do the rest of this all in your calculator. That's what that gizmo is worth to us today, $52,478.82. So really, that's what we should sell it for, ideally. Okay, so that's present value. When we talk about future value, this is where we talk about, okay, I'm using K because it's K years. This is, now we're investing our continuous income stream. So it's like we're continuously investing it as well. That's why we need an integral. We're not just like taking a big chunk of it every once in a while and putting it in, in an investment fund. So, right, P is the initial amount invested, or the present value. So that's the value of it, the future value after K years, depending on the rate R. So the future value is found like this. You just take that present value and you multiply it by whatever e to the RK is. Right, notice it's the same integral as last time. So we can essentially use the present value to easily determine the future value by just multiplying it by that factor of e to the r times however many years it is. Okay, so that's the future value formula. Example. A vending machine company is considering selling some of its machines. The income from these machines is a continuous stream with an annual rate of flow at time t given by f of t equals 12 times e to the negative 0.4 t plus 3. So this is an income stream that's a little bit offset by the factor of t plus 3. And then again, there's a negative in the exponential, which means this is a decreasing function, which should make sense because machines break down over time, right? It's not going to get more valuable in thousands of dollars per year. That shouldn't really matter, except at the very end, remember to put in, okay, it's that many thousand. Like if you get, 60 for an answer, well, no, it's 60,000. But for now, we just proceed. So we want to find the present value right now, and then the future value over the next 5 years if we're making 10% interest, which is pretty good. So buckle up, this one gets a little nasty. Present value is the integral from 0 to 5 of our income stream, 12e to the negative 0.4 t plus 3, times e to the, right, it's not 10 in there, it's 0.1, so it's negative 0.1 t. Really, this is going to be kind of the same as the last one, just the numbers are a little uglier. Take that 12 to the outside and then just combine those exponents by the rules of exponents. So I just went ahead and distributed those parentheses. So it's negative 0.4 t minus 0.4 times 3, which is 1.2, minus 0.1 t. That gives you what? E to the negative 0.5 t minus 0.12. So again, just think about the substitution rule. We don't really have to do it. Just think, what's the derivative of that inner function? The derivative of negative 0.5 t minus 1.2. The 1.2 doesn't appear in the derivative. So the derivative, du, is just going to be negative 0.5 like it was the last time. So all that's going to end up happening if you do the whole process is we're just going to end up dividing by negative 0.5. So you just do it. So it's 12 times 1 over negative 1 over 0.5, or just negative 12 over 0.5, times that expression, e to the blah, 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 evaluated from 5 to 0, because it's 5 years. And then we just kind of clean it up and plug stuff into our calculator as we go. Okay, so 12 divided by negative a half is the same as 12 times negative 2. And then again, okay, so it's e to the negative 0.5 times 5 minus 1.2 minus e to the 0 minus 0.12. So calculator time, apparently that's a negative 3.7, and that's negative 1.2. And then just stick all this into your calculator, however you do it, but in one big move. And you get 6.635. Remember, that's in thousands. So you could say 6.635 thousand, or it's probably simpler just to say $6,635.30. So like I was saying, the future value is just a number times that integral. So there's absolutely no reason to do the integral over again. We already did the work. We got the number. So just multiply that number by e to the r times however many years it is. Like that. So the future value is just like you take the amount that you're going to get from the investment, which is e to the 0.1, that's the rate, times 5, that's the time, times that number we got in the last one. So that's easy. If you have to do both in a problem, just do the past value first and then multiply by this number, or present value, I mean. Okay, and that's what you get, 10,939.75. So it's a lot more because you've been investing the money the whole time. But again, you're just taking into consideration things like, well, should I sell this machine now and get a new one? Stuff like that.